Hi, today we're going to look at examples of how to divide square roots. If you encounter a problem where you have a radical in both the numerator and denominator, and those numbers are divisible, you can simply divide and the answer stays under a radical. So 30 divided by 6 would be 5. So the answer to the square root of 30 divided by the square root of 6 would be the square root of 5. We can do the same thing for this one, square root of 150 divided by the square root of 3. When we divide, we would get the square root of 50. In our last problem, we couldn't simplify the square root of 5, but we can simplify the square root of 50. That would be the square root of 25 times 2. And the square root of 25 is a perfect square. That would become 5. So our answer here would be 5 radical 2. In this example, both the numerator and denominator have a coefficient. So we can think of this as two separate problems. We can divide the coefficients on the outside if they are divisible, and then we can divide the radical part. So 8 divided by 4 is 2. And 96 divided by 3 is 32. And now we need to ask ourselves if 32 can be simplified, and it can. So we're going to keep the 2 on the outside. 32 is 16 times 2. The square root of 16 simplifies to 4, which will be multiplied on the outside by the 2 that was already out there. So 2 times 4 is 8, radical 2. For this example, we have 5 times the square root of 33 divided by the square root of 11. We can think of there being an imaginary 1 out here in front of the square root of 11. So we would be taking 5 divided by 1, which is 5. And then the square root of 33 divided by the square root of 11 is just the square root of 3. And we cannot simplify 3 any further, so we are done. In this problem, there's no radical in the denominator, so we can just divide the numbers on the outside. 16 divided by 8 is 2. And then the square root of 40. And again, we can simplify 40. That would be 4 times 10. And then the square root of 4 is 2. And 2 times 2 is 4 radical 10 for our final answer. Now this example is going to be a little different. We have a radical in the numerator and denominator, but we cannot divide them. And we do not allow a radical to stay in the denominator. This would not be a final answer. So we need to do something called rationalize the denominator. And when we rationalize the denominator, we follow a process which allows us to eliminate the radical in the denominator. And that process is we take whatever the denominator is and multiply the top and bottom by that value. Now, if you multiply something by that number over itself, this is just the equivalent of 1. And if you multiply by 1, it doesn't change the value. So that's why this process is okay. We're not changing the value of the original expression. So we now have two fractions that we're multiplying. And to multiply fractions, we first multiply across the top. And since both of these numbers are in radicals, we can multiply them. The square root of 3 times the square root of 2 would be the square root of 6. And then in the denominator, we have the square root of 2 times the square root of 2, which is the square root of 4. The square root of 6 cannot be simplified, but the square root of 4, that's a perfect square, comes out as a 2. Every time you rationalize the denominator, If you're multiplying by the same number here, you will get a perfect square, which ends up being the number that you started with in the radical. Let's do another one where we have to rationalize the denominator. For this one, we have 5 divided by the square root of 3. Again, we can't divide here, and we simply can't divide because the square root of 5 isn't in a radical to begin with. So we will again rationalize by multiplying both the numerator and denominator by the square root of 3. Unlike the last one, we cannot multiply the 5 and the 3 because the 5 is not in the radical. So we just have 5 times the square root of 3. And again, multiplying on the bottom, we would get the square root of 9. We can't simplify the top of this fraction, 5 radical 3. That's as simple as that gets. But the square root of 9 will come out as a 3. Now we would just want to double check and make sure that we can't divide right here. If this was a 6 and a 3, then we could divide and get 2 radical 3. But in this particular case, 5 radical 3 over 3 is our final answer. Let's look at one more where we have to rationalize. We have the square root of 18 divided by the square root of 5. Again, we can't divide those, so we're going to rationalize by multiplying the numerator and denominator by the square root of 5. The square root of 18 times the square root of 5 is the square root of 90. The square root of 5 times the square root of 5 is the square root of 25. We can bring out our 25. That's a perfect square. So that's the square root of 90 divided by 5. We can't just leave this 90 though, because it can be simplified. That would be the square root of 9 times the square root of 10. And then the square root of 9 is a perfect square, so it would come out as a 3. So we have 3 radical 10 over 5. And again, if these numbers could be divided, we would simplify those. Hopefully this helps. You learn how to divide radicals both with and without rationalizing denominators.